Okay, so we're going to look at 2-4 complex numbers and operations, and our objective is to solve problems with complex numbers. So how can we represent and operate on numbers that are not on the real number line? Okay, what does that even mean? So imaginary numbers. So right now we've had X and Y, real number system, right? We could have fractions, decimals, percents, whole numbers, all the things, but we've always been in the real number system. So there's also an imaginary unit outside of our real number system, and that's when there's a negative underneath a radical. So the square root of -1 is defined as I. I don't know what that was, but it's defined as I. And it's usually written with a little curly at the bottom, or it's written in italics. So you can see this one over here, I italicized it, but usually it's written a little bit scripted. All right, so -1 is I, and also if I square I, so if we see I squared, it's -1, because if I square this, the square and the square root are going to cancel each other out. So I squared is -1. So if I see the square root of -1, it's I. And if I see I squared, I can replace it with -1. All right, so first of all, how can we even use square roots to solve an equation? Well, first of all, I know that if I have something like x squared equals a number, that I can take the square root of both sides. You did this in Algebra 1. I can take the square root of both sides and I put plus or minus in front of it. And so I get two answers. X equals plus or minus the square root of whatever that number is. Maybe you had to break it down, maybe you used a calculator, but I get two answers there. All right, so a complex number, let me just go ahead and answer this question. A complex number looks like a real part and an imaginary part. So a plus bi is a complex number. A being the real part and b being the imaginary part. And the I helps us recognize the imaginary part. All right, so let's talk about square roots, using square roots to solve an equation. So I can take the square root of both sides of this equation. I make sure I put plus or minus in the front. The square root and the square cancel out. So I'm left with x equals plus or minus the square root of 49, or x equals plus or, I don't know why my equal sign keeps doing that. X equals plus or minus 7. All right, so what happens when there's an I in this mess? All right, so let's look at this one. I'm going to take the square root of both sides again, plus or minus. So x equals plus or minus the square root of -81. Well, let's talk about this negative first of all. That means plus or minus the square root of -1 multiplied by a positive 81. And if you remember with square roots, I can split them apart like this. So that still means the same thing. When I multiply radicals or square roots together, I multiply what's underneath. I multiply the outside stuff also, but I multiply what's underneath. And so I can split this so that it looks like this. The square root of -1 is I. So I have plus or minus I, and then the square root of 81 is 9. So plus or minus 9i. Right, so that doesn't have a real part. It just has the imaginary part of this complex number. This one, just the real part, no imaginary part. All right, so let's put those together. Let's see what happens when we add or subtract complex numbers. When we do that, we put the real parts together and we put the imaginary parts together. So that would be the B part, imaginary, and the real would be the A part. All right, so we want to put the real parts together, the real numbers together, and the imaginary. So let's just look at number 2. What is the sum of 3 minus 8i and 9 plus 6i. So we are adding these together. Do you see I have the real numbers 3 and 9, and then I have the imaginary part, a negative 8i and a positive 6i. So we're just going to keep real with real. So 3 plus 9 is 12, and then a negative 8i and a positive 6i is a negative 2i. So that is my answer to the difference between, or the difference of those two. Sorry, the sum of those two. Sorry, sum of those two. All right, let's look at the difference. So the difference, it just means we're going to subtract. But I'm going to teach you a little hack here. We can change this sign to an addition sign and push the negative through. So it's like we're saying negative 2 plus 4i plus a negative 1 times 5 minus I. And then I am going to shove that negative 1 through the parentheses. So I'm going to distribute it to both of those. So negative 2 plus 4i, I'm going to drop the parentheses also, plus 4i, plus a negative 5i, plus I. So I multiplied by negative 1, which just, sorry, there's no I with that. Let me get that out of there. I multiplied through by negative 1, so it just changes the sign. So negative 1 times 5 is negative 5. Negative 1 times negative I is a positive 1i. All right, so I just pushed that negative through. Now I'm going to add the real parts with the real parts, imaginary parts with imaginary parts. There it goes. All right, so real parts, negative 2 and negative 5 is negative 7. And 4i and 1i is 5i. All right, so negative 7 plus 5i, and that is in the correct form, a plus bi. So I'm going to leave that one for you to do. All right, and then how do we write the product of complex numbers? So product means now we're going to distribute. So I want you to notice there's a difference between how this is written and these two. This one had an addition sign, this one had a subtraction sign, this one had a subtraction sign, so we know we're adding or subtracting. But if we have product, there's no sign between them. So I have to distribute. I have to multiply the 2 through to both. And then I'm going to come back and multiply the negative 3i to both. All right, so let's do the 2 first. So 2 times 6 is 12. And 2 multiplied by negative 2i is negative 4i. Right, now let's grab the negative 3i. Negative 3i multiplied by 6 is negative 18i. And negative 3i and negative 2i is negative 6. And I times I is I squared. So we talked earlier that when we see I squared, that we can replace it with negative 1. So let's go ahead and do that. So I have 12 minus 4i minus 18i minus 6 times negative 1. So every time I see I squared, it's going to change the sign of the number, right? Because I'll be multiplying by negative 1. So I have 12 plus 6, which is 18, because that made that a positive 6. And then I'm going to put these together, minus 12i. So that is in a plus bi form, and that's the product of those complex numbers. So here's one for you. This is your turn. All right. Okay, how can I write a quotient? All right, so let's try 4 over 3 minus 2i. All right, so quotient means I have a division problem, right? I cannot have a square root in the bottom of a fraction, and I is the square root of negative 1. So I multiply by the conjugate. Hopefully you know what the conjugate is. If you don't, I'm going to tell you, of course. So the conjugate, the complex conjugate, means if I have a complex number, a plus bi, the conjugate is a minus bi. So it's the opposite sign of b. All right, a stays the same. We just change the sign in the middle, and then we multiply. So 4 times 3 is 12. 4 times 2i is 8i. And then on the bottom, this is a perfect square. So when I multiply 3 times 3, I get 9. Sorry, difference of squares, not perfect square. Difference of 2 squares. When I multiply 3 times 2i, I get 6i. Then I'm going to come back and I'm going to get negative 6i. So my middle stuff goes away. And I have negative 4i squared. But we know that I squared is negative 1. So we'll mark that out and just change the sign of the 4. This stuff in the middle is going away. So 12 plus 8i on the top, and then 9 plus 4 is 13 on the bottom. So another way that we could write this is 12 over 13 plus 8 over 13i. And that would be an a plus bi form. All right, so something to think about: if I'm solving a quadratic equation and my solutions are complex numbers, what does that tell me about the graph of the quadratic function? So if I'm setting factors equal to 0, remember that helps me find x-intercept. So what happens if they both have an I? That means my graph doesn't hit the x-axis. I have solutions to the equation, but they are not x-intercept. So either A is positive and it opens up and the vertex is above the x-axis, or if A is negative, my parabola opens down and my vertex is below the x-axis. So that's what could happen. All right, your turn on this one, and I will see you guys soon. Make sure you grab these that are your turns, all right? This one, you can check this one out by graphing and or setting it equal to 0 and trying to solve it. But that will actually, I think this is from the last, but you could totally do this too. But factor out the negative 1 and factor it. See if it'll factor or see if it has imaginary roots. All right, I'll see you guys soon.